Hello again, Grizerel here. Today we are continuing on the same topic as last video, where we compare the original character stat system with a new implementation. So let's take a look at the implementation for both systems now. The character stat system, as you may already know from my videos back many years ago, the character stat system consists simply of the character stat class. That's about 120 lines of code, give or take, and the stat modifier struct, which is not even 50 lines of code. So in terms of implementation, this system is that simple. I would argue it's hard to come up with anything simpler than this for this purpose. And in contrast to that, the new system has a default stat class, but then that derives from an abstract stat class that you could use to extend and implement your own stats if you want. So it's a little bit more extendable in that way. But that does mean that the implementation turns out to be quite a bit more complex. So there's the default stat class, then you have an abstract base class for that, which implements the stat interfaces. There's also multiple different interfaces. There's a stat, there's a read-only stat. There's also different types of stats, actually. Beyond this abstract one, you also have simple stats. So you have a simple additive stat, multiplicative, max, and min. So yeah, as you can see, there's quite a lot more stuff overall. So that means the system as a whole is a bit more difficult to understand if you want to know all of the inner workings of everything. But hopefully it's actually more extendable from a programming perspective, and you can do more with it. Okay, so for a proper overview in this video, let's just have a look at the interfaces first. And let's start out with the most restrictive ones, let's say. And that is iRead-only stat. So similarly to the iList and iRead-only-list interfaces, I have implemented a iStat and iRead-only stat. And as you may immediately notice, one thing that can be a big advantage in the new system is that a stat can contain other stats. So if you want to, say, have your attack damage depend on your strength and your agility, you can make a stat that contains strength and agility, and that calculates its final value based on a formula that depends on those two other stats. And then, fundamentally, a stat also has, of course, a base value and a final value. There's also a iRead-only stat with a generic t parameter, and this t represents a type of stat modifier, and we will have a look at the implementations and interfaces for those in a second. But then the differences between this interface here and the above one is that the stats list now also contains stats of the same type with the generic parameter. And also, because here we have information about stat modifiers, we can also provide the number of modifiers that this stat may have, and a function to give us a list of all of those modifiers. Also, given the names of these interfaces, these should be read-only, so none of the variables have any set accessors, only get, and all of the lists are returned as read-only lists, so you can't modify any of the contents of it. Moving on to the iStat interfaces, these extend, or more appropriately, these implement the read-only interfaces, but they essentially override, or the correct term would be they hide, the inherited members of the stats list, which now returns a iStat and also the base value, which now has a set accessor rather than just a get. So in this version, things are modifiable. So in addition to being able to change the base value, now you can also clear all of the modifiers of this stat. And just like in the other interface, there's also a version that has a generic parameter. And in this one, since now we have proper information about stat modifiers, this also exposes functions that allow us to add and remove modifiers. And for the stat modifiers themselves, the stat modifier struct now only contains the value, really, and then it has a generic type that you are free to implement yourself in any way you like, as long as you also make it a struct that is enforced by this generic constraint here. And in this data object, you can have, well, whatever you want. So in this sense, the new system is more flexible because it allows you to implement custom stat modifiers with custom data. The only thing that's always required is the value. So this stat modifier struct also implements the iComparable and iEquatable interfaces. And for the stat modifier data interface, that's what it looks like. So the main one, if you want to implement your own modifier data, the interface that you would use would be this one, with a generic constraint. And I know this may be a little bit weird, because if you take a look at the generic constraints here, the generic type t is actually itself a stat modifier data of type t. So this basically references itself, and I know this can be a little bit weird, but the main reason for that is that we want to enforce that the implementation of this interface is a struct, and the only way to do that is with this generic constraint here, using the keyword struct, but then we also need to specify that this type is itself a stat modifier data. So that's why it looks like it's kind of a circular dependency, but the C# compiler can handle that just fine. And actually this version here of the interface that doesn't have any generic parameters is actually not being used right now, so it could theoretically be safely removed with no side effects. We can see that it compiles just fine without any errors, but I like to keep it here because it may be handy if you ever need to type check for a stat modifier data when you don't actually know its generic type. For example, if you need to write some editor code or something like that. And one other difference that I would like to highlight here between the new system and the original is that the default implementation, instead of being a single big list of modifiers, now it's actually composed of multiple different stats, and each one of those stats handles one of the modifier types. One of the disadvantages of this separation is that you can no longer override the order of modifiers as easily. So in the previous system, you were able to have one specific additive modifier, for example, apply somewhere in between multiplicative and multiplicative total modifiers, or anywhere you want it. This time, it's not as easy to do that, although it's still possible if you make a custom implementation. But one of the big advantages of that is that when you have all of the additive modifiers separated in their own space, adding and removing them becomes almost free, because there's no sorting that ever needs to happen this way. Since addition and subtraction can be done in any order, it's literally just a matter of adding or subtracting the new modifier from the value that you already have. That's one of the properties of addition and subtraction, is that they are commutative, which means that any additions and subtractions can be done in any order, and the result will always be the same. And the same thing is true for multiplications and divisions. So adding and removing additive or multiplicative stats becomes a matter of literally just one math operation without the need to do any sorting in between the modifiers. And as we saw in the performance portion of this video, in certain circumstances that improves the performance massively. For max and min stat modifiers, that isn't always the case. Sometimes we still have to recalculate the whole thing because the value of the modifier is dependent on other modifiers, but it still opens up lots of situations where we can optimize and not do certain calculations unless we absolutely have to. So that's the overview for today. I hope you enjoyed it, and in the next video we will start implementing all of these classes, so I hope to see you in the next one.